Alright, so what we're going to go through today is go through the detailing for your footings. So we went through wet areas last week. I think in combination with that video and also those example plans I've put online, so on the Learn page there should be plenty of info for you. And yeah, and once again, have a look at those example plans for some things that they include in regards to footings as well, general notes, etc. But also beware that the footings we're going to be doing for this building are different to the ones in the example plans. They're different to some of the details that are given, so you're going to have to be bringing some things together. It's about sort of going back to your source documents for information and then pulling things together from there. So your footings for this one are possibly a little bit trickier than for a lot of your standard stuff. Because also if you did just type in Google search footing beam, like footing edge beam detail, 90% of the detail, well actually you'll get all sorts of details, but you'll get details with really deep rebates and by and large you're going to get details for brick veneer which have a rebate. Our style of footing is not going to have a rebate given the cladding that we're putting on here. So we're pulling together some information from various different sources. So our first most important source of information is the engineer's report. So all of you should have that engineer's report. Now that engineer's report, it gives you the dimensions of the house there, but you can see from the spacings of it that at what centres your internal beams are located. If you're going to be drawing any sections through here, you probably want to space them the same. But one of the important bits of information there is actually down in a lot of this writing. So I'll make that larger. Well, first of all, we've got I1 and E1. Probably no points going for anybody who can tell me what they are, but can anybody tell me what I1 and E1 stands for? Yeah, that's it. Yeah, your external beam, your internal beam. Because sometimes they're the same, sometimes they're different. So that should be delineated. They will be on your engineer's information. I'll try to get that, because that's still not readable to everybody, is it? But that might be better. Right. Okay. So then in our footing schedule, we've got E1 and I1. Oh gee, it's a bit difficult to read those. At 850, I think it's.
Scroll out once more.
Okay.
It'll make it clearer.
Oh, so go back. Yeah.
Yeah, go back and get clearer.
Yeah.
It'll still say pretty blurry though.
Yeah. Anyhow, so they're going to be 850 deep. I'm pretty sure from memory. Those you can see it a bit clearer than the snip that I got for putting it into these slides. But you've got your depth and your width. So that's the first bit. So you draw in, and also with all this detail stuff, you're going to be doing that with detail lines as well, rather than just take a section through the building, because the building hasn't really been set up for that initially. So you draw your depth. Now, as I mentioned before, because this is a frame and cladding building, because we don't have brickwork, we don't have a rebate happening, so you can draw your beams really simply. Then we've got four N16s. So N16, that means a bar which is of nominal ductility. I can't remember how ductile the nominal ductility bar is, how much you can stretch. Ductility relates to how much a product stretches, how you can stretch it out. Look, I can't remember. But anyhow, nominal ductility is slightly stronger than the old Y bars. So there was so we've got N's and we've got Y's. Sometimes you'll see plans that refer to Y's. But pretty much everything, all the reinforcing you buy now is nominal ductility. So N12s. Anybody tell me how thick an N12 bar is? diameter? No? No? An N12? Oh,
Just
that's
stab in the dark, it's 12 millimeters.
12 millimeters, yeah, that's it, yeah, yeah. So these aren't quick trick questions, these are, yeah. So yeah, so your N16s, they're 16 millimeter bars. So when you draw them as your little circles, you draw, you know, your radius 8 millimeters, you get a 16 millimeter bar. And they, you know, you have a look at the work that's being carried out with the extensions of the freeway and everything here, they're using 32 mil bars there. But N16s, that's a pretty decent sort of bar actually for residential footing. Your mainstay is N12s. Then we've got, I'm pretty sure it says in here we've got 2 top and 2 bottom. So 2T, 2B. So for 2 top and 2 bottom, if we draw a cross section through our slab, this, like our beam, that means we've got 2 bars at the top, 2 bars at the bottom. Really simple. That all of that is included in there. And then this one over here, I'll move the cursor around for those at home. We've got ligatures. Ligatures are the piece of wire that hold all those bars in place. So they're actually fairly solid pieces of wire because they have to stand up to things wanting to collapse under weight, and there's a fair bit of weight that ends up getting put on these reinforcing cages as you put all the mesh and things like that, and people start walking around on it, etc. So they're typically 8 mil ligatures. So, and that under there it says W8 at really what 900 centers, I think. Yeah, 900 centers. So W8's at 900. So W just means wire. So 8 millimeter wire at 800 centers. Now, so 8 millimeter, that's actually a very thick piece of wire. So that's all the information really we need to have about our reinforcing cages in our beams for us to be able to draw those beams. Well, it's getting there. There's some other things. There's information here about slab mesh, etc. But I'll go into the slab mesh a little bit more. But there's some summary about that. So 100 millimeter slabs, SL92 top, with 25 millimeters of cover. Whenever we put reinforcing into a concrete slab or concrete at all, we have to think about concrete cover. For a couple reasons, is that the steel, it bonds with that concrete, and everybody here knows the reason why we put steel into concrete, don't you? Yeah.
To prevent oxidization.
Uh,
And to reinforce concrete.
Yeah, yeah, exactly. Because a piece of concrete, if I just poured a piece of concrete and I stood on it, I'd snap that easily. Put a piece of steel in that bit of concrete, you won't